Hi everybody, Patrick here from EngineeringShock.com and EscapeRoomElectronics.com. This video will serve as the video manual for the Little Buddy Talker. If you haven't already checked out the Kickstarter campaign, it is linked below. It's got a 254-word library, so you can use your Arduino or any platform capable of communicating via SPI as a master to a slave. You can get the Little Buddy Talker to say all sorts of neat things using the 254-word library. I digress. Let's get back to it. So what you'll need is a platform to control it. And for this video I'll be using Arduino. You'll need a Little Buddy Talker fully assembled, and you'll need a stereo cable. Now if you pledge towards a reward tier that didn't include a stereo cable, don't worry about it. You can go to any dollar store and pick one up. They're very cheap, very easy to come by. Which is why only two of my the reward tiers actually include them. It's just it's cheaper to actually buy them at the dollar store than they are to import. In any case, I've got one hooked up right here. We're going to make the connections twice using two different kinds of cables. But first things first, let's just get the easy part out of the way so we've got more room with our camera. You're going to want to hook up one side of your stereo cable to the stereo jack on the Little Buddy Talker, and connect the second side to the stereo input on any amplifier speaker set. I'm using my computer speakers. Now as you can see, we've got this plugged into a breadboard. You can also plug it in easily to a piece of prototyping board if you'd like to solder it in place. That's completely up to you. Right now I've got male-to-male pin connections to the Arduino and the side pins of the Little Buddy Talker, and I'm going to show you how to make those connections, but I'm also going to show you how to use the included male to female pins on the back side. So first things first, let's have a quick look at the connections on the back and on the sides. Now these indicators are likely better seen at the Kickstarter campaign because they're very small, but on the bottom board or the side of the board we can connect to 5 volts, GD, which is ground, and then the rest of the pins are NA for not applicable. On the top of the board we've got 5 volts, GD, DI for data in, SC for system clock or S clock, C and CS for chip select, and these are our SPI communication pins. We got clock, data, and chip select. And on the back of the board we've got the pins facing the top that we can connect to using male to female connections, which we'll be doing again as well. And we've got 5 volts on the upper side, GD for ground, DI data in, SC system clock or SPI clock, and CS for chip select. So first things first, why don't we connect our Arduino to the side pins using male to male connections. We can connect our power supply, 5 volts and ground, here, here, or here. Let's use the bottom of the board. So I'll connect ground to any of the ground pins on the Arduino. Let's use a red wire or an orange wire to connect 5 volts to the 5 volt pin, like that. And then on the top of the board what we can do is we can connect S clock or SC. Doing this with the camera in the way is a little bit difficult, you'll have to pardon me. 1, 2, 3, 4, so SC to pin or GPIO 13. Let's connect DI to GPIO 11. And lastly, let's connect CS, chip select, to pin 10. And that's all you need to do. So let's give that a quick power up. I've got the code in the Arduino set to play all of the words consecutively, and so all you need to do is apply power and it should start playing all of the words in order. Now all I need to do is plug in power.
Color: black, white, blue, green, orange, red.
Now let's rip out our connections. And what we'll do is we'll connect on the upper side using male to female connectors. Same connections as before. First things first, let's connect let's say an orange one. It doesn't really matter what, as long as you make the right connections. 5 volts to the 5-volt line. Just use this is the closest I have to black. Let's try gray to ground. Or sorry, GD to GND on the Arduino board. And next is DI. DI goes to GPIO 11. Next is SC for system clock or SPI clock, and that goes to 13. Next we've got chip select, and lastly I should say, and that goes to GPIO 10. So now I'm just going to zoom out and I'll plug in power again.
Color: black, white, blue, green, orange.
So it's that simple. Upload the code, make your changes. There will be 3 sample codes. There will be one showing you how to use arrays to play sentences, one that just the code that's on here right now that plays all 254 words in succession, and there will also be one that just shows you how to call words, a very simple one that just shows you how to call any random word as you like. So say I want to call the word January, it'll show you how to call that word on the fly. So now that we've looked at how to hook this up, why don't we look at our oscilloscope and have a look at the data lines. So if you want to mimic this using a different platform, you have an idea what the SPI communication protocol looks like. I'll reset the program. So this is our clock line, and it's normally low. When it's transmitting, we get pulses of about 1 microsecond long, and there are 8 pulses here, 8 pulses here. This command byte always stays the same, and that's the first to be sent. And the data line is normally high and is brought low when it's transmitting data. So the command byte right here always stays the same when it's saying, okay, get ready to send the address, and the second byte in the word being transmitted is the address to the of the word itself. Now I've turned the stereo off just so that I can hear myself speak over the little buddy talker. But this is just incrementing from 0 to 254 before resetting back to 0. So this line, this data line right here, is incrementing. And so right now we've got 0, 1, 0, 0, 0. It's going too fast for me to follow with it, but it's incrementing. By the time this reaches 254, the data line should essentially be one straight line at 5 volts. So there you get that. So what I'll do now is I'm going to remove the data line from this equation, and I'm going to look at the chip select line. The data line will still be doing its thing, but I got to show you what's happening with the chip select line, and this oscilloscope can only handle two signals at once. Chip select is normally high, normally 5 volts, and it's brought down, it's cleared to 0 volts for transmit. So this tells the little buddy talker, okay, I'm about to talk to you, and once the data is sent, the clock line is set again, or sorry, the chip select line is set again, and that data transmission has completed. So data and chip select are normally high and go low when transmitting, and the clock is normally low, and transmission pulses are high, and then once the transmission is done, it goes back to 0 volts. So hopefully that gives you an idea in case you wanted to use your Raspberry Pi or your PIC microcontroller. I've used Little Buddy Talker with the PIC microcontroller, a PIC 18F1220 and an 18F2221, which are very similar chips relative to the architecture of the code. But I've never used a Raspberry Pi. Raspberry Pi should be just as compatible, and this will work at 3.3 volts. It'll actually supposedly work down to 2 volts, the chipset. I've never tested it at 2 volts, but a 3.3 volt power supply should work just fine. In fact, just for fun, why don't I hook this up to the 3.3 volt pin power supply on the Arduino Uno. Sorry, my furnace is just turned on. There might be some background noise. I apologize for that. I'm going to reset the program. I'm going to turn my stereo on.
Color: black.
We're powering this with 3.3 volts.
Green, orange, red.
And as you can see, we're
yellow,
incrementing.
Purple. Abort. Activate.
I'll
Deactivate. Destruct.
reset one more
Go.
time. So
Color.
0,
Black,
1,
white,
2, 3, 4, 5, 6, 7, 8,
purple,
9, 10,
activate,
A,
begin,
B, C, D, E, F,
deactivate,
and so on. So it goes 0 to 254,
open,
and this is powered with 3.3 volt line. So again,
stop,
completely
turn,
compatible with
January,
Raspberry Pi or other
March,
3.3 volt
April,
platforms.
May,
So I'm going to
June,
turn my stereo
July,
off, my computer speakers. It's still, the program is still running, but I've turned my stereos off so I can essentially talk to you. This is the Little Buddy Talker video manual. I appreciate your time. Again, if you've pledged towards the campaign or you're thinking about it, or even if you've checked it out, thank you so much. The support behind this campaign has been tremendous, and I'm working extremely hard to get rewards shipped out as soon as the 2-week period after the campaign ends. I'm currently programming the chips. The hardware is being assembled, and the accessories are actually already in transit to me. So things are going great, and the campaign doesn't end for another 15 days. So I am really on track of things here, and I'm just so happy that the campaign is going so well. So thank you very much for watching. This is the Little Buddy Talker. It's small, it's inexpensive, it's powerful. Take care, everyone.